Good afternoon, ladies and gentlemen. Seeing as this, fortunately, it's a smaller group than it could have been, so we need less ice breaking, but I'm nevertheless going to share with you this one, because this is sort of taking me back a couple of years. You know, I was with the CSIR some time ago, so this is a bit of a memory trip, and at the risk of wasting too much of my 30 minutes, I should share this one with you because it dates back to those years, and seeing as not too many of you are my peers, I would guess, in terms of years, I trust that not too many of you have heard this one before. But it does date back to those years. It's a story about the minister who had this habit of putting up his sermon on the pulpit ahead of the service, and this little boy came and he pinched away a page. And the dominie was going like this, he was saying, "And Adam said to Eve, and Adam said to Eve, there's a page missing." So that does date back a while. On that note, thank you very much. It's a great privilege for me to be here this afternoon, but also a great pleasure, but intimidating because it does take me back down memory lane. And I'm going to share a little bit in some way with you about that. Credibility base. This is part of the Aerosud, at least the RLAC presentation. I just took this one slide out of there, RLAC aircraft, because you see, this takes us back to what I've just referred to, National Institute for Aeronautics and Systems Technology, 74, around about 1974, where we in fact did the first Alpha XH-1 helicopter, which was the precursor to the Royfok program. And this is where the bit comes. This was done in the CSIR when I was here. And this is the disconcerting part. That was me. I think it's apparent that I'm still recognizable after 40 years. Some 40 years on, and it does concern me some. Let's first talk about aerospace manufacturing in South Africa. Today, we see a number of important OEMs and their super tier 1 suppliers in South Africa, quite active in South Africa. The biggest of which is obviously Airbus and Boeing. And then we have seen the emergence of the two primary South African tier 1 manufacturers, Denel Aerostructures and Aerosud. And I didn't see any Denel guys here. If there are, just let me know. But with old Theo Kleinhans's agreement, I'm going to just show his slide in a minute as well. And then we're seeing also now the third one emerging, which is in fact RLAC, which I'm going to touch upon as well this afternoon. In the process, please let's not forget that there are other guys. I'm not trying to say these are the only guys. Yonkers Sailplanes, Airplane Plane Factory, etc., which are doing wonderful work. And I think we should recognize them as well in their own right. But looking at that situation just briefly, talking about Denel Aerostructures, we know it's part of the Denel Group. We know that they've got about 550 million turnover per annum. They're just over 400 staff, 25,000 square meters of facility. They're well established by way of an international customer base. And as you all will know, they have quite a complex product portfolio. Secondly, we have Aerosud, whom I represent this afternoon, and I will be expressing, obviously, industry related viewpoints, but unfortunately, certainly I must admit to being obviously looking at it from an Aerosud perspective. Aerosud started with manufacturing in the commercial aviation environment. It was formed in 1990, which means it's 25 years this year. But insofar as commercial manufacture goes, commercial aviation manufacture, it started in about 2001, just around 9/11. And it has built up today through a series of major programs to being a single source supplier, and pretty much all of them today. So there's, in effect, no longer a 737 or an Airbus 320 going off the production line without an Aerosud part on it, which we are quite proud of. We are heading well towards 1 billion per annum now, 1.4 million parts now. It reminds me of that little song that says, I ain't going to impress the motor industry much with those volumes, but by aviation volumes, that's fairly substantial. about 850 staff members and growing at the moment, and then we've signed the 4th renewal of the Boeing contract recently. Talking about ARLAC, Advanced Reconnaissance and Surveillance Aircraft, that's what it looks like. I'm sure you're all aware of it, and just where we are right now at this particular time, we've now completed, touch wood, as I've earlier said, I trust there's no varnish in the middle between being a technical man. 150 hours of flight testing is now done. We are in the process of building the second prototype, and the production facility, first time we really say this in public, is now being launched at Wonderboom Airport. So let's go back and look at South African industry. Strong points of the South African industry is obviously that we have a credible and reliable global brand name established with the Boeings and Airbuses of this world. Both ourselves and our partners in industry, Denel Aerostructures, and I will have you know it's very important that we realize that there's extremely good cooperation between Denel and Denel Aerostructures and Aerosud these days. We're really beginning to strongly mutually support one another. Aerospace is, however, a low-volume, high-variability business. It's less focused on mass production and repetitive skills, and therefore has a stronger focus on engineering parity, technology, innovation, problem-solving, etc. And for that reason, we are experiencing or sensing that the OEMs are increasingly less interested in this low-cost outsourcing than they are industrial partnership. My good friend Simon Ward, Senior Vice President, International Cooperation, sitting at the back there. Simon, I'm saying that tongue-in-cheek. I trust you'll forgive me if you don't agree. Government, DST and DDI support for know-how intensive industry, hugely important. We'll be talking, I think you guys, particularly in the CSIR, well know and realize that. DST, CSIR as a technology partner, I'm not saying that conveniently at this point in time, and strategic minerals as such as titanium, and then we're seeing the emergence of programs like ARLAC. We look at that, and now moving on towards an Aerosud perspective. Okay, so what's this about? How do we see ourselves levering advantage into the future for local manufacture? South Africa is a small industry and a small, relatively insignificant global player. We have to recognize and accept that. We cannot be everything to everybody. Second major factor, whether people like this or not, whether this is a popular statement to make or not, the fact is that we are not recognized internationally as being highly productive in terms of our labor force. Fact. So the conclusion for that is that we must certainly avoid brute force labor-intensive productivity competition. The Mexicos, the Indias, how many others out there? These guys are good. And if we try and brute force up front compete with them, we're not going to get there. Conclusion is we have to pick niches of excellence where we have some leverage, starting with our established markets. Obviously, our existing primary partners being Airbus and Boeing. That is hugely important to us to start off from. Building from there on partnerships both locally and international, capitalizing on the absolutely unique past experience and not allowing that past experience to leak away. We all recognize today that things have been done in South Africa for the wrong reason. Nobody argues that. But don't miss the point that a lot of that has been done with good effect. If it hadn't been for things like Royvalk, Aerosud would not have existed. If Aerosud had not existed, ARLAC as an aircraft would not have existed. And this is a fact. So we've got to build on that past experience base and not allow it to leak away. On top of that, we've got to underpin it with the very initiatives that are currently under discussion. For example, titanium beneficiation, very, very important. And finally, please, we have to believe in ourselves and capitalize on SA can-do mentality. Own up to it, own our own IP, and develop from there. Looking at characteristic differences, just trying to say what, from an Aerosud perspective, we think should be done. First is, what is the difference between the aviation sector and the other sectors? If we look at, for example, motor industry, it's a high volume, low value industry. Not where, in my humblest of humble opinions, South Africa is necessarily good at. If we look at the aerospace industry, it's high value, low volume, exactly the opposite. And therefore, for the motor industry, it's a matter of focusing on automation. For us, it's a matter of focusing not so much on automation. Of course, the big guys can do that, but on process optimization. We really cannot always justify massive levels of automation. And finally, we have to all be working in this global context, at reducing time and cost to market. We have to cut waste. We have to minimize things such as industrialization. Now, comes a term which we have been generating amongst ourselves for some time, the critical importance of chain silos. What do I mean by that? If we look at, and I, from this point onwards, look at the whole situation from an aerospace perspective. The problem with international aerospace is that it is unfortunately bogged down by its own bulk. Huge organizations, huge supply chain inertia, and therefore it's extremely difficult to change. Give you a simple example. You know, a major OEM would have to outsource its manufacture of components. If it doesn't do that in-house and is vertically integrated, it has to outsource it. Now, that company that it is outsourcing to has already its own programming team, it's got its own machining infrastructure, etc., etc. So it's almost impossible to feed through new changes in terms of design philosophy, such as design for manufacture, but because you've got to take this inertia of all these other guys with you, along with you. Very difficult. Second factor is, and that doesn't count for me, it's all my other colleagues, seniority, age, and leadership. What happens in the industry? By the time a new program is started, who leads it? The senior guys in the organization. Unfortunately, the guys who say, hey, but this is high risk, we know how to do it, we know how to do it in such a way that the risk is contained, how we will be applying our experience. And in the process, what do? You are inhibiting innovation. So there's major resistance to change. Now, South Africa being an emerging new industry with a very, very unique past experience base. This is really important that we understand this. Those programs were for the wrong reasons. Let's make peace and come to terms with that. But they have created a local level of experience. It's quite unique. We're sitting with relatively small companies in South Africa with experience base on par with really, major international organizations. We have to realize that and recognize it and not allow it to leak. And therefore, I contend that South Africa is a really perfect environment for what I refer to as a greenfields change silo, which means we control enough of the parameters to make change that we can actually effect change. If we don't control it, it's all outside, it's all sub-tier supply. And it's a huge, massive organization. We cannot as readily influence the factors that will bring about change. Sharing some Aerosuit perspectives. So what was the journey if we look at it from an Aerosuit perspective? 2001, make to print. Moving on to design and manufacture, A400. Now we are moving on to IP ownership, where we own the IP. It's interesting to our overseas partners, and therefore they keep on contracting us. Not necessarily because of offset. Of course, that's a leverage that we all are grateful for. But principally because we are creating niches of excellence where we own IP, which is of interest. Let's talk briefly about the Aerosuit Innovation Center. To us, that constitutes a spearheading activity in terms of developing partnerships for the future. Hugely important. We're part of the global business, we have to create partnerships. It was created in around 2005 inside of the Aerosuit Group for the purpose of generating or stimulating strategic imperatives for the future. What are these imperatives? Typically, the ones I'm going to touch upon is niche manufacturing technologies and production process optimization. Just very briefly this afternoon, share some ideas with you. If we talk about niche manufacturing technologies with IP ownership, obviously the one that you've listened to this morning, our partnership with the National Laser Center and the CSIR around laser additive manufacture. Perfect example of what we mean by developing niches of excellence where we share the ownership of IP, and therefore are soliciting the interest of the major OEMs worldwide. It is a big challenge for those that are not necessarily familiar with it. And going back, I'm sure, Hardus, you said that this morning as well, but just to repeat, the key interest from an aerosuit perspective and from an RLAC perspective lies in the fact that the normal traditional processes go through a hugely complex logistic process, eventually ending up machining most of that material away, turning it into swarf or waste, whereas additive manufacture gives us a much shorter cycle from cradle to grave or cradle to utilization of the material, and much less wastage. In fact, we look at conventional machining. In the aviation business, we talk about using billets to manufacture and machine very lightweight components, which ends up machining something like 90+% of that billet away. So we go and buy it from overseas at a huge price, bring it in, and then promptly turn it all into swarf. Whereas with processes which give us near net shape capability, such as additive manufacture, we reduce that to something like 5%. Massively interesting to us in becoming more competitive. I think this process, thanks to Hardus, Marius, our man from Aerosuit side, Hardus Greiling from the National Laser Center side, and obviously Pat and your entire team, and the CSIR more generally, fantastic teamwork. And I'm not saying this for the convenience of the occasion, it is really true. We've seen fantastic teamwork. I think it's a brilliant example, and it certainly fits into our Aerosuit and RLAC perspective of what is important, built on established markets. Our relationship, for example, with Airbus, who certainly have strong interest in titanium parts, local international partnerships. We will be talking about that in the coming months quite intimately. Innovative can-do mentality in South Africa, proving it yet again to ourselves, perpetuating past experience, and, for example, around lasers, we should really be grateful for the fact that there has been laser technology established in South Africa, because now we can tap into that and bring industry and the CSIR to give it together, and then strategic resource beneficiation such as titanium. Vastly important. Let's briefly then, heading towards the end of the presentation, talk about RLAC as an aircraft and why that is so important. Over and above the fact that it seems to be highly, highly interesting aircraft, there's quite a lot of market interest. I'm not going to talk about that here this afternoon. Let's talk rather about the significance of this program in terms of where we're trying to head from a technology perspective. We use this as a medium to develop concepts which everybody else in the world is dreaming about. Things like design for manufacture and digital manufacture. Why is it difficult? Let's just look at that. Look at prototyping versus series production. Prototyping must be highly innovative, whereas series production, the worst thing that can happen is that during production you're innovative in terms of what you manufacture and how you manufacture it, not in terms of processes, of course, but you want the process to be highly stable. In development, you are probing extremes and unknowns. In manufacture, you want mature processes and technology. You require in development constant firefighting, whereas that's the last thing you want to happen with you in production. And so it can go on. And I can tell you that these worlds are very, very much apart and very, very difficult to relate to one another, to bridge that gap. It's just been very, very difficult. And this is where this concept of a chain silo comes in, that I've been referring to this afternoon, and explain to you a little bit in more detail, just by way of a few slides, what we really mean by that. The first thing is, a chain silo means you've got to control enough of the parameters, the success parameters, bottom up, that will bring about change. So, if you have your organization distributed over 4 countries, over 10, 15 companies, etc., engineering teams all over the world, guys coming from all of these different programs, coming together as contract designers, for example, in one organization, you come up with a huge inertia of preconceived ideas, preconceived way of doing things, and infrastructure that is binding people together. So what did we do in the Innovation Center? And this particular slide is very interesting, because the very same concepts that we pioneered in the Innovation Center is in fact what we are currently applying in the design of the new factory at Wonderboom Airport, which is now happening. So what you see here is photographs of the Innovation Center at Aerospace, whereas here you see actually the layout of the first production factory. What you have to do is you have to get to a level of highly integrated design. You've got to vertically integrate that. CNC programming, forming, machining, CMM, assembly facility, all into one shop. A silo for the moment, so that you just can, for the moment, control these parameters and change things. So it's highly important that you get these two things together. How you lay out that whole building. Another thing is, it's imperative that we use the latest digital design tools such as CATIA, that's an industry standard for aviation, and digital prototyping. What do I mean by that? If you look at the functionality of things like CATIA today, kinematics, how you can model in the same very model that you're creating for the aircraft, which typically looks like that, you can now at the same time use to animate that model, to introduce kinematics. You can have the control surfaces moving and so forth. So, another very important point, let's talk about design for manufacture, a dream of the aviation industry. We want to cut out this industrialization phase because it consumes too much time, it's too complex and a lot of money. So what you need to do is to bridge that gap far more efficiently. So what we've, for example, done in this particular instance is to go and do a very interesting thing. Up front for the team, we selected the very machines that they were going to manufacture this prototype on. And then we said to the team, you're going to manufacture those prototypes using those machines. Don't come and tell me that the part is too big for the machine, and therefore you've got to go to supplier so-and-so and get a big enough machine. We picked the machines up front. Now you design in accordance with the capacity and the capability of that machine. That we did. CMM, I'm not going to bore you with detail. If you can't measure, you don't know. As jy nie meet nie, weet jy nie. Old truth. So you need proper CMM. And what you've done doing that, you've said, okay, I'm going to digitally design, I'm going to CNC program parts for CNC manufacture, I can kit those and I want to assemble them, and in the process I'm also closing the loop with CMM measurement. What does that look like in practice? A hugely important element of ARLAC has been what we call jigless free build. We no longer use jigs. Sometimes in the aviation industry we tend to be very arrogant. We think that we're years ahead of the motor industry. Contrary is true, the opposite is true. Motor industry has had to, as a consequence of commercial realities, move along. And only now is the aviation industry catching up. For example, how you de-skill the process, how you speed it up. One of the key things here is, for example, jigless manufacture. So what are we doing? We take a spar, we pre-machine it, all the rivet holes are pre-drilled. Then we assemble onto that fluid-formed D-nose ribs, that's what we call a D-nose rib, that one sitting there. We pre-rivet it, we form it, we pre-drill it for all the holes. We do the same with the stringers and we do the same with the skins. The skins are also interesting because we pre-form them, we flat form, drill all of the holes. And we develop the capability of then forming the shape, and all of this has to go together like a Meccano set. Zero, and we've literally done that on ARLAC. Zero manual parts manufacture. All from CATIA directly onto programming, onto machines, onto press forming, onto drilling, etc. By the time the skill comes to the table is when we finally assemble the wing or the parts. And for those that know the aviation industry, clecos, 100%. We need 100% fit on the clecos. So that's a very typical route that we follow, just to illustrate some of our thinking to you, why we need to cut cost, cut timescales. I didn't want to include that slide, but If you take the build of the first fuselage, the center fuselage of ALAC, 1st of December it started, and about the 5th of March, we started the engine and the electrics and engine on that system. Within a matter of 3 months, first prototype, it just went together, poof, like that. Role in this context of additive manufacture. Waste reduction is obviously, we use a lot of pocketed monolithics in that aircraft, deliberately, for a number of interesting reasons for those that are interested in this dimension. Why? Because to cut cost, we need to cut parts count. To cut parts count, we need something that we call monolithic machining. We manufacture from bulk, from blocks of aluminium. If we do that too much, we create too much waste of material, and therefore monolithics being manufactured by things like laser additive manufacture is highly interesting to us. Another dimension of the same thing is where we say they're highly complex, high-strength parts, and we can increase again the complexity of those parts by, if we did that with conventional machining, we end up with parts which are just too expensive, too complex, and these aren't necessarily even good examples of those. These are high tensile strength parts, which we have to then be machining from billet or bulk, and they will take 20, 30, 40 hours for one part to machine. So, wonderful breeding ground for us to develop laser additive manufacture applications. ALAC has some more than 80, and I didn't realize or Marius was that many. I last had a figure of 50 in my 55 in my head, but I'll believe you guys. Around 80 parts already manufactured using other forms of additive manufacture. Mainly plastics and ducting, air inlets, etc. Also a very interesting process, and also very important to the international aerospace fraternity. There's a lot of interest for this. So that was just by way of giving you a bit of a glimpse of why we are doing these things, trying to cut down cost, trying to cut down time to market, simplifying processes, increasing the efficiency of those processes, and then obviously doing other things like parts count reduction, waste reduction, etc., etc. I thank you for that.